Hello everyone. This video is on the Knewton Alta assignment, section 3.4, part 3, called Properties of Composite Functions. Alright, so in this video, I'm going to be doing a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same, so I'm hoping that the questions are similar enough so that watching me do a few here helps you out in some way when you work on it yourself. Alright, so here's the assignment page. You got your title, your mastery bar, the objectives. Looks like there are 2 objectives here. And under the current objective, there should be a question related to that objective. Then at the bottom of every question, there should be a feedback button where you can send feedback to Knewton. You will not have this instructor cheat button. It's for instructors only. But you will have the more instruction button. Click on this if you're ever struggling with a particular topic. You'll be taken to a page with some reading or some videos, and you'll be given questions related to that instruction, and hopefully that helps you get through the assignment. Alright, so this first objective I'm looking at is finding the domain of a composite function. Alright, so before I get into this question here, let me talk about that a little bit. Now I'm hoping from sections 3.4 parts 1 and 2 you remember what a composite function is. And I'll still write it here, the notation for a composite function. Looked like this. It was, if I had a function f and g, the composite function f composed with g would look like this. Right, f composed with g of x. Now another way to write this was, f of g of x, right, with all these parentheses like that. Basically, x goes into g, right, then whatever g of x is, then goes into f. Right, and you calculate the output there. Now, you can also switch this, do g composed with f, and then it would be g of f of x. So you just gotta pay attention to the order. The order matters when you're composing functions. Now, the domain of this function f composed with g can be explained the following way. Alright, it's a set. Right? Remember, domain is the set of all the inputs, right? The set of all the x values that can be used to give me a real number output. So it's the values of x such that x is in the domain of g right, because that's the first function it goes into. So since I'm plugging in the g first here, x better be a number that's in the domain of g. And at the same time, g of x, right, whatever that first output is in the domain of f. Now, how we're going to do this. Right? The steps I'm going to take. First, I'm going to state the domain of the first function we're plugging into. Alright, and the first function we plug into in this case is g. If it was g composed with f, the first function would be f. So you just pay attention. But for f composed with g, first I'll state the domain of the first function we're plugged into, right? State the domain of g. Then compose, actually form the composite function, make f composed with g, and find any further restrictions to the domain after composition. You'll see what I mean when we get to some examples. If any. Right, there may not be any further restrictions after you find the domain of G, but this is how I'm going to go about finding the domain of any of these composite functions. Alright, so our first example, right, this first question, we're given the following. F of x is the function 1 over 6x minus 12. And this other function g of x, is a square root. It's the square root of 2x plus 4. Right. And we're asked to find the domain of f composed with g. Now, as I was saying, the steps. First, I'm going to state the domain of the first function we plug into. Then I'll compose the functions and look for any other restrictions that might need to be made. So you see, the first function we plug into is g. Now remember, for square roots, the radicand, right, the expression underneath the square root, can't be negative. It has to be greater than or equal to 0. And if that's the case, that means that x has to be greater than or equal to negative 2. Right? So there's the domain of g. Right? It's all the values greater than or equal to negative 2. Right? So right now, those are the values I can plug in. Negative 2, negative 1, 0, 1, 2, 3, anything greater than negative 2 or equal to negative 2. So now let's compose. All right, so that was step 1. Right? Find the domain of the first function we plug into. Step 2, let's actually compose the functions. Remember, this is f of g of x. So basically, I just take g of x and plug it into f. Right? So instead of 1 over 6x minus 12, it's 1 over 6 times the square root of 2x plus 4, and then minus 12. And now that I've composed and I'm looking at the function, right now I say I can only plug in numbers negative 2 or greater, but are there any numbers that can be taken out of that set as well? Are there any further restrictions? Right? Any further restrictions? Question mark. Well, there's a denominator with a variable in it in this composite function. And remember, denominators can't be 0. So 6 times the square root of 2x plus 4 minus 12, right, this denominator, I'm going to say, when is this equal to 0? Right, when is that equal to 0? Now, this is a radical equation, right? You would add 12, divide by 6, you have the square root of 2x plus 4 would be equal to 2. Square both sides, 2x plus 4 equals 4. Subtract 4, divide by 2. X must be 0 here. So there's a further restriction. Further restriction, yeah, x can't be 0. Right, because if I replaced x with 0, this denominator would be 0 in the composite function. So putting them both together, I put my original domain, the domain of the first function we plug into, put that together with the restriction, and we get the following domain, right? So the domain of the composite function, f composed with g, it's any value of x that's greater than or equal to negative 2, but not 0. Right. So if you were doing interval notation, that would be from negative 2 up to 0, parentheses on 0, right? Bracket on -2. -2 is fine. 0 is not. And then there's a gap, right? Union. And then everything from 0 to infinity would also be fine. Just not 0. All right, so here it is. This is the domain of this function, this composite function. So again, one more time. I find the domain of the first function I plug into. Then I compose it and find any further restrictions if there are any. All right, and let's see what they had. Now this is a multiple choice one. All real numbers other than -2 and 0? No. You couldn't plug in numbers less than -2. All numbers greater than or equal to 2 other than 4? No. It's this last one here, right? All real numbers greater than or equal to -2, but not 0, right? Other than 0. All right, then after you submit, you should be told if you're right or wrong. Given some answer explanation, please read through the answer explanations, especially if you got it wrong. All right, hopefully you can figure out why you got something wrong and maybe learn from your mistakes for the future. All right. Next question. All right, still on the same objective, find the domain of a composite function. And once again, we're given a function f and a function g, and we're composing them in this order: f composed with g, and finding, asked to find the domain of this composite function. All right, so once again, I'll write these out and do it on some paper. All right, so function f of x equals, we have -4 divided by -x plus 4. Now, personally, I don't like all the negatives, so what I'm going to do is I'm going to multiply the numerator and denominator by -1, make that +4 in the numerator, and if I multiply the denominator by -1, that'd be x minus 4. It's just a personal preference. I just don't like that negative lead in the denominator. That's just me. You can leave it this way if you wish. And then the other function, g of x, is -8 divided by -2x minus 6. And once again, just a personal preference. Multiply, I don't like that negative lead in the denominator, so I'm going to multiply the top and bottom by -1 again. That's +8 over 2x plus 6. And I could even go further with this. You could factor a 2 out of the denominator here, make it 2 times x plus 3, the quantity x plus 3, and cancel the 2. The 2 goes in 8 4 times. And then the 2 would be gone down here, and you'd have x plus 3. Right? So me personally, I try to make it look as nice as possible before moving on. All right, so now we're asked to find the domain of f composed with g. Right? Or you could write it this way, right? F of g of x. All right, so as I was saying, first let's find the domain of the function we're first plugging into, which is g. So what's the domain of g? Well, the domain of g is all value. I can plug in anything for 1 except -3. Right, here's g. If x were -3, the denominator would be 0. So it's all x, right, as long as x is not -3. All right, and if you put that in interval notation, that'd be from -infinity to -3, union -3 to +infinity. Right? It's all real numbers except -3. All right, now let's actually compose, and this will be the tricky part most of the time. So I'm just replacing, I take g of x and plug it into f. So I'm taking this here, 4 over x plus 3, and I'm plugging it in for x in the f function. Right? So we have f of g of x is going to be 4 over, And then instead of x minus 4, it's this, right? It's whatever g was minus 4. So I'll have what's called a complex fraction, 4 over x plus 3, and then minus 4. Now I'm hoping you remember how to simplify complex fractions, from a beginning algebra class or something. And multiply the numerator and denominator here by the quantity x plus 3. And there's two terms down here, so that needs to be distributed. So in the numerator, I'll have 4 times the quantity x plus 3, which I can distribute later, make it 4x plus 12. Then in the denominator, the first fraction here, the x plus 3's would cancel, and I have 4 minus, 4 times the quantity x plus 3. We could go even further with this. If I factor a 4 out of the bottom and distribute the negative here, the 4's will cancel with the numerator. You have x plus 3 in the numerator. And then if I pull a 4 out, that'll be 1 minus 1 times x plus 3. So I'll have negative x minus 3, but then plus the 1 be minus 2. So hopefully you can see that x can't be negative 2. And if you don't like the negative lead, multiply the top and bottom by negative 1, and you get x plus 2. But we're seeing the further restrictions after I simplify that. All right, any further restrictions after composing? Do you see anything? Well, yeah. X can't be negative 2. Because if x were negative 2, you'd have a denominator of 0. Or even going back here, right? Maybe you saw it here in the beginning after I composed. If x were negative 2, right? Negative 2 plus 3 is 1. 4 divided by 1 is 4. 4 minus 4 is 0. You'd have a denominator of 0, and that's bad. All right, so then putting these together, the domain of the composite function is basically all these numbers, right? All the numbers except negative 3, but now also no negative 2 either. So it's any value of x as long as x is not negative 3, and at the same time x is not negative 2. And you can put this in interval notation as well, but again, it's multiple choice. But here it is, right? Here's the domain. All the numbers can be plugged into this composite function except negative 3 and negative 2. So going back here, that's this option here. Wonderful. Okay, next question. All right, now we're at the other objective. Decompose a composite function into its component functions. So basically tell me what function was plugged into what other function to make this composite function. All right, so they're asking for what would f and g need to be so that f composed with g gives me this h function here. Now, see how g is inside f? So basically if you see something in parentheses, that's going to be g. Or inside a square root, or inside a denominator, inside grouping symbols of some kind. So let me show you what I mean. All right, we're given this h of x equals, the quantity 4x plus 1 to the 5th power. And you see how, this looks like 4x plus 1 is inside, something to the 5th power, say x to the 5th. All right, if I were to take 4x plus 1 and plug it in to replace x with it, I'd get h back. So this is the inside function, this is the outside function. I'm going to call this g and this f. All right, so f of x is x to the 5th. G of x is that 4x plus 1. And then we can check, what's f composed with g? This would be, put g into f, it would be the quantity 4x plus 1 to the 5th, which is h. Check. Right, so these are what they want, the component functions. Right. what functions can I compose to make the function we were given. So back here, of the another multiple choice one, looks like this one works, the very first option. Oh, it does say select all that apply. So you could run through here and see if they also, because let me show you also, that's not the only possibility, right? Or I could have had, f of x be x plus 1 to the 5th power, and then g of x be just 4x. All right, because if I plug 4x in for x, then all of a sudden it's just 4x plus 1 to the 5th. So there are like multiple possibilities. Usually you try to look for the simplest one with the biggest inside function, like this one here. This would be more useful for a calculus class, because you're going to learn you're going to have to be able to do this pretty well in calculus to perform derivatives of functions like this, doing something called the chain rule for derivatives. But again, I'm not going to get into any of that. That's not the point of this video. All right, so let's just look through the other options and see if anything else would give us that particular function, this quantity 4x plus 1 to the 5th power. Well, the second one, if I plugged in g to f, I'd have 4 times the quantity x plus 1 to the 5th. That's not the same. Here, if I plug g into f, I'd have 4 times x to the 5th plus 1. That's not the same either. This is the other one I mentioned, right? X plus 1 to the 5th, and then g is 4x. If I plug 4x in for x here, you get that function back. So this option also works. And this one doesn't. If I replaced x with x plus 1, I'd have 4 times the quantity x plus 1 to the 5th, which is totally different. Alright, so look through all the options, compose the f with the g, plug g into f, whatever you want to say that, and see which ones give you the same as h. Multiple options here. Okay. So again, composing and figuring out which ones work. If I were to, this first one looks good, right? If I replace the x in this f function with negative 8x plus 4, I would, I'd get function h back. This one, nope. Again, it's something you just kind of have to practice and see. You can write these out if you wish. This one works. If I replace the x here with negative 8x, it looks exactly the same as h. So this one works. This one, no. This one, nope. Nope. All right, so just those two options, right? Again, and go through and practice composing all of them. Make sure they look the same as h. Again, I'm just going to kind of talk these all out. All right, so one more like this with the commodity. All right, so if I have negative 1 over x to the 9th for f, and then negative 6 minus 8 for g, that'll work. So like this. But also if I had negative 1 over x minus 8 to the 9th, and then g was negative 6x, it doesn't look like any of these work. This would work, because negative 1 to the 9th power is still negative 1. And then you'd have the negative 6x minus 8 to the 9th in the denominator. So that one works as well. Not this one. Not that one. Not that one. And now if this were the other way around, it would work. If I plugged, if they said g composed with f, it would equal h, but not f composed with g, right? They want f composed with g. So just the two that I selected. And again, play around with it, write them out, compose them. You should know how to compose by now, and see which ones give you the something equivalent to the original function h they gave you. Alright, and then same one more of these here. So 8 over x to the 6th, if that was f and g was 9x plus 3, that would work. So this option. Let's see. Not, that would be 9x to the 6 plus 3 in the denominator. No. Nope. Not quite. Not quite, because we don't have 8 to the 6th power in the numerator. And no, not here either. Well, it looks like only the one option. Oh, it does say select the correct answer below. They're circles instead of boxes instead of squares, so there's only one option that's right anyway. Ooh, read your instructions, folks. All right, and again, please read through the answer explanations. These just kind of, after writing out a few of them, you'll get the hang of it. I wrote out that first one, but again, after a while, writing out a few of them, getting the hang of it, you should be pretty quick at seeing component parts of composite functions. Alright, so the last couple problems should be back to that domain. Alright, find the domain of a composite. So I'll go back to writing these. Right, these are a little trickier. Alright, so we're given function f of x equals 1 over negative 10x plus 3. And again, if you want to multiply the top and bottom by negative 1, you can. Right? This would be the same thing as negative 1 over 10x minus 3. Same stuff. And then g of x is 1 over negative 5x minus 6. Again, if you want to multiply, if you don't like the negative lead in the denominator like I don't, multiply the top and bottom by negative 1, you got negative 1 over 5x plus 6. And these are the same thing. And once again, they are asking us for the domain of f composed with g. Right, or again, you can write it this way, f of g of x. So first thing you plug into is g. So that's going to be the first function I state the domain for. Right? What's the domain of g? Right, so the domain of g is all values of x except what makes the denominator 0 would be negative 6/5. Right? X can't be negative 6/5. Because if I plugged in negative 6/5, you'd have a denominator of 0. G would be undefined. Alright, now let's actually compose and simplify and see what we get. So f composed with g, again, just take g and replace all the x's in f with it. Right. So this would be negative 1 over, and then instead of 10 times x, it's 10 times whatever g was, right? Negative 1 over 5x plus 6. And then you got minus 3 after. Alright, then if you want to simplify this a tad, again, another complex fraction here. Multiply the numerator and denominator by the quantity 5x plus 6. And that should get rid of the denominator of 5x plus 6 there. So basically in the numerator I have negative 5x minus 6 after distributing the negative 1. Then down here we'd have, the 5x plus 6 is canceling in this first term, so you have negative 10. And then minus 3 times the quantity 5x plus 6. And distributing the negative 3, combining like terms, we get the following. So we have negative 5x minus 6 in the numerator, and then negative 15x minus 18, but then minus 10 would be minus 28 in the denominator. And once again, I don't really like having a negative lead in the denominator, so I'm going to multiply the numerator and denominator by negative 1, get 5x plus 6 in the numerator, and then 15x plus 28 in the denominator. Now, are there any further restrictions after you compose? Do you see any other values of x that can't be plugged in? And I do. X cannot be equal to negative 28/15. Because if x were negative 28/15, the denominator of this composite function would be 0. And then we put these together. The domain of the first function and the further restrictions we find. Right, so the domain of f composed with g here, it's, I can plug in whatever I want for x as long as it's not negative 6/5 and it's also not negative 28/15. And that's what they want right there, the domain. And it's a little crazy with the fractions, but they happen. And another, okay, we just have to type it in ourselves. Report your answer in fraction form when necessary. If there are multiple intervals, use the union symbol. So we're supposed to put this in interval notation, right? They're talking about intervals here. Right? So let me go back to the paper. So in interval notation, now negative 6/5 is negative 1.2, and negative 28/15, that's almost negative 2. It's closer to negative 2 than it is to negative 1. It's more than negative 1.5. So this is the furthest left on the number line. Right, if you had a number line, negative 28/15 would be to the left of negative 6/5. And neither of these are in the domain, but everything else is. Right, everything else is. So we got three intervals here. We got from negative infinity up to negative 28/15 union, right, because there's a break in it. And then from negative 28/15 to negative 6/5, and then another break, another hole, union symbol, and then from negative 6/5 to infinity. This is what they want us to enter, right, in interval notation. And that's what I'll do. So we have in parentheses, right, from negative infinity up to, right, comma in there, negative 28/15, and close the parentheses on this, and then we got the union symbol here, and then from negative 28/15, comma, up to negative 6/5, and again parentheses on that. Negative 6/5 is not included in the domain. Union again, and then from negative 6/5 up to infinity, right? Everything beyond negative 6/5 is allowed to be plugged in. There's the interval notation. All real numbers except negative 28/15 and negative 6/5. Great. All right. And again, please read through the answer explanations. All right, moving on. Should have just one more of these with the find the domain of a composite function. And I'm doing the same steps. Sorry, this one's a multiple choice one. And it's another one where f and g are both fractions, rational functions. So let's do that again. So we got f of x is 1 over negative 10x minus 7. Again, I personally do not like having a negative lead coefficient in the denominator. So that's negative 1 over 10x plus 7. Multiplying the numerator and denominator by negative 1. And g of x is 1 over negative 6x plus 5. Again, you can keep it this way, but I have a personal preference here, so multiplying top and bottom by negative 1 be negative 1 over 6x minus 5. And then we're asked to find the domain of f compose with g. All right, so first, the domain of g, right? The first function we plug into, our input needs to be in the domain of that function. Well, this is all x except 5/6. Because if x were 5/6, the denominator would be 0 in the function g. Now let's compose. So f compose with g. Again, you're just taking g and plugging it into f, right? So everywhere there's an x up here in f, you replace it with this whole thing that g is. So that'd be negative 1 over, and then instead of 10 times x, it's 10 times negative 1 over 6x minus 5, and then plus 7. And then I simplify a bit. Again, we multiply the top and bottom by the quantity 6x minus 5, and that'll be distributed down here. So we have a negative, I'll just keep the quantity 6x minus 5. Then down here we'd have negative 10 plus 7 times 6x minus 5, and then distributing the 7 and combining like terms, I might as well distribute the negative up here. Negative 6x plus 5 divided by 42x, and then you have minus 35 minus 10, so minus 45. Okay, there's our composite function, and then any further restrictions? Yeah, x can't be 45 40-seconds, but this is 3 times 15, this is 3 times 14, so 15/14. All right. X can't be 15/14. So put them together. X can't be, 5/6, and at the same time, X can't be 15/14, right? And there's the any other number but that. That's the domain of the composite function. Right? All the values we're allowed to plug in for X. Right? And this one's actually multiple choice. Again, so all real, that's the very first one. All real numbers except 5/6 and 15/14. Wonderful. All right, so yeah, that's a little more involved, I feel, than the other one. The other objective where you're just finding the component functions. This one involved a little more writing, a little more thinking, I feel. And that should be it for this preview version of this assignment. As I said at the top of the video, please understand that the questions I saw here are not going to be the same questions you see, but the objectives are the same, right? So I'm hoping that the questions are similar enough here so that watching me do a couple here and there will help you in some way when you work on the assignment yourself. All right, and thank you very much for watching.